Good afternoon, everyone. So, today we are going to discuss definite integrals. Definite integrals. So, suppose here let f of x integral of f of x is equal to f of x dx is equal to capital F of x plus c, then integral of a to b f of x dx is equal to, that is f of x plus c, and limits are a to b, where a is called lower limit and b is called upper limit. So that by substituting upper limit, it becomes x is equal to b. If you substitute here, it is f of b plus c by substituting upper limit minus lower limit, which is a, x is equal to a, then it becomes f of a plus c. Therefore, here where c is the constant of integration, so they get cancelled. Therefore, that is equal to f of b minus f of a. This is called as definite integral of the function f of x over the interval a to b. F of x is a function defined in the closed interval a b, then integral of a to b f of x dx is equal to f of b minus f of a, where capital F of x is the integration of f of x. Here we get the definite value we are getting here, so that it is called as definite integrals. F of b minus f of a is a sum, that fixed value you will get here, definite value we are getting here. So it is called as definite integral, whereas indefinite integrals, suppose for example, if you take here integral of sin x is there, integral of sin x dx is equal to, we can write minus cos x plus c, we can write, where c is constant of integration. That means what here, it is this is minus cos x plus some root 2, it is also integration of the function sin x, and that is minus cos x and plus some 2 or 3 something. So like this, these are all integration of that function only, it is not unique. So that it is it is the indefinite integral. So because for c, where c is the arbitrary constant, so that these are all integrations of this function only. So that it is indefinite integral, whereas in this case we are getting the some quantity, fixed quantity, therefore it is called as definite integrals. Now, so today we can go through the properties of definite integrals, properties of definite integrals, properties of definite integrals, properties of definite integrals. Say first one, that is integral of a to b f of x dx is equal to integral of a to b f of t dt, that is changing the variable. So integral of a to b f of x dx also can be written as integral of a to b f of t dt, or some other variable you can take here, integral of a to b f of y dy. It is true for any variable. So in this case, here f of x dx, f is a function of x, so we have to integrate that function with respect to x. Then these are the limits of the function x. This is called lower limit, this is upper limit. Similarly, here variable is t and here variable is y, so that these are all equal here. This is the first property of definite integrals here. Integral of a to b f of x dx is also equal to integral of a to b f of t dt, and also we can write integral of a to b f of y dy, whatever the variable we can change like this, and that is equal. Now, here if the limits are equal, suppose here integral of a to a f of x dx, integral of a to a f of x dx is equal to how much here? 0. That is, if upper limit and lower limit are equal, then its integral value is equal to 0, because here f of a minus f of a, that will be equal to 0 will get here. Similarly, now third property, that is integral of a to b f of x dx. F of x dx is equal to, that is, if you interchange the limits, then sign changes. That is, here if you interchange the limits, suppose here a to b is there, that limits if you write it as b to a, then we'll get minus. Minus of f of x dx will get here. By interchanging the limits, then sign changes, sign of the integral changes. Here it is plus sign is there, so that we get minus of integral of b to a f of x dx. This is the changing of interchanging the limits, then sign changes. And next one, it is integral, that is integral of a to b f of x dx. Splitting the limits, that is, here suppose c is a real number lies between a and b, then we can write this as integral of a to c f of x dx, integral of a to c f of x dx, plus integral of c to b f of x dx, like this. Okay, integral of a to b f of x dx, where c is a real number which lies between a and b, then that can be written as split into two integrals like this, a to c f of x dx plus c to b f of x dx. Now, here suppose if the integration of this function f of x is capital F of x, if you take here, then the limits are a to c, you can write, plus integration of this function is capital F of x, and here limits are c to b. Therefore, by substituting the limit, upper limit, that is f of c, will get here, minus, we are going to substitute lower limit, then it becomes what here, f of a. And similarly, in the second integral, that is upper limit is b, so that it is f of b minus f of c. So that minus f of c and plus of f of c get cancelled. Therefore, that is f of b minus f of a will get here. So, f of b minus f of a means it is nothing but integral of a to b f of x dx. Therefore, like this we can split the integral. If c is a real number between a and b, then this integral can be written like this, a to c f of x dx plus c to b f of x dx. So, this can be written for any finite number of real numbers. Suppose here if c1 is less than c2 less than c3 and so on, cn less than b, and here it is greater than a. These are the real numbers between a and b. Then that integral can be written as, here it is integral of a to b f of x dx can be written as integral of a to c1 f of x dx plus integral of c1 to c2 f of x dx plus and so on, plus integral of cn to b f of x dx. Like this we can write split into n number of integrals like this, where c1, c2, c3 and cn are real numbers between a and b. Then this integral can be split into n integrals like this here. So, next one is the important property here, that is integral of a to b f of x dx. Integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. This is the important property of definite integrals. Integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. Now, here in this, suppose here if you put a plus b minus x, a plus b minus x is equal to t. Then we are substituting a plus b minus x is equal to t, differentiating on both sides, then this is constant, this is also constant, so that it becomes here 0. Therefore, now a plus b, that is 0 minus dx is equal to dt will get, or we can write dt is equal to, it is dx is equal to, it is minus dt we can write here. Therefore, now here that is equal to integral of a to b is equal to that is here integral of a to b f of a plus b minus x dx. Integral of a plus b minus x dx can be written as by substituting a plus b minus x is equal to t, then dx will be minus dt, and we have to find if you substitute like this, then limits also changes here. Then these are the limits of a. Now we have to find the limits of the variable t. So that we have to substitute here, that is lower limit of x is a, so you have to put x is equal to a. Then a get cancelled, t is equal to b will get, that is the lower limit. That is the lower limit here. So here lower limit is that is b you will get here. And if you substitute the upper limit of x here, then bb get cancelled, that is a you will get, integral of b to a. Therefore, integral of b to a f of t, you can write here f of t because we are substituting a plus b minus x is equal to t. And dx is equal to how much here? Minus dt, so that you can write here minus dt. So for overall you get minus sign. Instead of that, you can, by interchanging the limits a to b, you can write here, so that this becomes positive here. Just now we discussed about the interchanging the limits, then sign changes. Therefore, then this becomes positive here. Minus is there, so it becomes positive. Then we can write here f of t dt. F of t dt. Integral of a to b f of t dt. Therefore, that is also equal to a to b f of x dx. You can write it as for any variable that is equal to a to b f of x dx here. This is the first property of definite integral. It is true for any variable here. So this is equal to a to b f of x dx. Therefore, this is an important property in definite integrals. By using this property, we can solve many problems here. Now, integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. Integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. So by using this property, we solve some problems here. Suppose here you can take integral of, that is minus pi to 3 pi, minus pi to 3 pi log of secant theta minus tan theta is there. So take like this. We have to find the integration of this function. Integral of minus pi to 3 pi log of secant theta minus tan theta d theta is there. So now let I is equal to integral of minus pi to 3 pi, given integral we are denoting it by capital I. So log of secant theta minus tan theta, secant theta minus tan theta d theta. So you take it as 1. Then by applying this property, we can write this I can be written as I is equal to integral of minus pi to 3 pi. By applying this property, that is integral of a to b f of x dx. So that is here we get a plus b. A plus b means it is 2 pi here. A plus b minus theta. 2 pi minus theta will get here. That is here if you denote this by f of theta, then we get it as f of 2 pi minus theta will get d theta. If you denote this function as f of theta, then by using this property, a plus b minus theta becomes what here? F of 2 pi minus theta, because a plus b is 2 pi here, 2 pi minus theta d theta. Therefore, that is equal to integral of minus pi to 3 pi, and f of 2 pi minus theta here that is f of theta is equal to, you can write log of secant theta minus tan theta, Then what is f of 2 pi minus theta? So that it is log of secant of 2 pi minus theta, it is secant theta only, fourth quadrant. So, and that is tan of 2 pi minus theta is minus tan theta, so that it becomes plus tan theta will get. That is the value of f of 2 pi minus theta. So it is log of secant theta plus tan theta will get. So that now we can write here, it is log of secant theta plus tan theta you can write, d theta. Then you take this is 2. And now here 1 plus 2, equation 1 plus equation 2. Then LHS becomes I plus I becomes 2I. Here this is equation 1 and this is I is equal to this is equation 2. By adding LHS, I plus I is 2I is equal to integral of minus pi to 3 pi. Because here the limits are same, so we have to add under the same limits, we have to add these two functions. It is log of, here we get log of secant theta minus tan theta plus log of secant theta plus tan theta, log of secant theta plus tan theta d theta, like this we get d theta. Therefore, we know that log m plus log n is log m into n. So log m into n means secant theta, log of secant theta minus tan theta into secant theta plus tan theta, it becomes secant square theta minus tan square theta, which is equal to 1, identity. Therefore, here you got it as integral of minus pi to 3 pi. You got it as log of 1. Because here log m plus log n equal to log of m into n. Where m is secant theta minus tan theta and secant theta plus tan theta, which gives the product secant square theta minus tan square theta, which is 1. And we know that log 1 value is 0, so that is finally you got it as 0. Therefore, 2I is equal to 0 means that is I is equal to 0. 2I is equal to, you got it as 0. Therefore, I is equal to 0, where I is the given integral, we are denoting it by I. Therefore, this value is how much you got here, it is 0. Like this we can apply this, by applying this property, we can solve this problem here. So, we solve one more problem. One more problem we will take. Integral of 3 to 6 root x by root of 9 minus x plus root x dx. Integral of 3 to 6 root x by root of 9 minus x plus root x. Here it is f of x is equal to, that is root x by, here f of x is root x by root of 9 minus x plus root x. This is f of x. Now, f of a plus b minus x, a plus b means it is 3 plus 6 minus x. That is equal to how much here? F of 9 minus x will get. Okay. So, f of 9 minus x means that is root of 9 minus x divided by root of 9 minus 9 minus x will get, and plus root of 9 minus x. So, that is equal to, here it is root of 9 minus x by, it is root x will get here, because 9 get cancelled, minus of minus is plus, and plus root of 9 minus x you got here. That is f of a plus b minus x. Because here we have to do this problem by using the property, that is what here, integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. A plus b minus x dx. Okay. Now, so let I is equal to, given integral you can denote it by I. So that is what here, integral of 3 to 6, it is root x by root of 9 minus x plus root x dx. You take it as equation 1. So, by applying this property, we can also write this I as integral of 3 to a to b, that is 3 to 6, f of a plus b minus, this is f of x here. We have to replace this by f of a plus b minus x, which you got like this. So that I will write directly here, it is root of, already we calculated here, by f of a plus b minus x here, because integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx. F of a plus b minus x dx, that is equal to, you got that one, that we are writing here, by root x plus root of 9 minus x dx. This you can take it as 2. Now, here equation 1 plus equation 2 gives you 2i is equal to LHS, I plus I is 2i. So, that is integral of 3 to 6 will get here. By adding these two terms under the same integral between the same limits, then we have to add these two, then it becomes what here, it is simply will get it as dx, because these two are having the same denominator. So that we have to add the numerators, root x by root x plus root of 9 minus x by root of 9 minus x plus x root x. Therefore, numerator and denominator will get cancelled. So, 1 into dx, that is dx will get here. Therefore, that is 2i is equal to how much here, integral, that is x you got here, and limits are 3 to 6. Therefore, that is 2i is equal to, by substituting the limit, it is 6 minus 3 you got here. Therefore, 2i is equal to 3, then I is equal to 3 by 2, where I is the value of given integral is equal to 3 by 2. So, this suppose here if the limits are like this, 0 to a f of x dx is there. So, that is equivalent to 0 to a f of a minus x dx. A plus b is a will get here. So, this is if the limits are 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now, here integral of, one more problem you can take, integral of 0 to pi by 2, integral of 0 to pi by 2. So, integral of 0 to pi by 2, that is log of, here you can take 4 plus 3 sin x, 4 plus 3 sin x by 4 plus 3 cos x, 4 plus 3 cos x dx is there. You take like this. Integral of 0 to pi by 2 log of 4 plus 3 sin x by 4 plus 3 cos x dx. We have to find the value of this integral here. So that you can take, let I is equal to, given integral you can take it as I is equal to. Then by using the property, that is what here, integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Okay. So, you take this is equation 1. By applying this property, this integral can be written as, where a is pi by 2 here. That means what here, we have to replace x by pi by 2 minus x. Then what it becomes here, sin of pi by 2 minus x becomes cos x, and here cos of pi by 2 minus x becomes sin x. So, that we have to write here, that I can also be written as integral of 0 to pi by 2. Integral of 0 to pi by 2, it is log of what it becomes here, 4 plus 3 cos x will get, divided by 4 plus 3 sin x, 4 plus 3 sin x dx, by applying this property. A minus x means pi by 2 minus x. We have to replace x by pi by 2 minus x, then it becomes like this. You take it as 2. Then 1 plus 2 gives you equation 1 plus equation 2. that gives you LHS becomes what here? 2i. 2i is equal to integral of 0 to pi by 2. Integral of 0 to pi by 2. First one is what here? Log of, it is 4 plus 3 sin x. 4 plus 3 sin x by 4 plus 3 cos x. 4 plus 3 cos x plus log of 4 plus 3 cos x. 4 plus 3 cos x by 4 plus 3 sin x. 4 plus 3 sin x and dx. Dx like this. So then here it is log a plus log b, that is equal to, we can write here log of a into b, so that here this is, suppose if a by b, this is in the form of b by a, they get cancelled, so you get log 1 will get. Log of a plus log b is equal to log of a into b, the product of these two terms is equal to 1. Therefore, the 2i is equal to, how much you got here? 2i is equal to integral of 0 to pi by 2, it is log 1 you got here, log 1. Integral of 0 to pi by 2 log 1, that dx, and we know that log 1 to any base, that is 0, therefore it's totally it becomes 0. 2i is equal to 0, then I becomes what here? It is 0 will get. So like this, by applying that property, we can solve these type of problems here easily. Next property, that is integral of 0 to 2a f of x dx. Integral of 0 to 2a f of x dx is equal to, that is 2 into integral of 0 to a f of x dx. F of x dx. If f of 2a minus x is equal to f of x, if f of 2a minus x is equal to f of x and is equal to 0, if f of 2a minus x is equal to minus f of x, if f of 2a minus x is equal to minus f of x, then its value will be 0. Okay, now we will see this property. So this is also one of the important property here. Now you can see integral of, that is here it is integral of 0 to 2a f of x dx. So we can write this as integral of 0 to a f of x dx, integral of 0 to a f of x dx plus integral of a to 2a f of x dx. Now, see this second integral can be written as, you are, so by substituting put x is equal to, suppose here you can write 2a minus t. Then dx is equal to, it is minus dt will get. Dx is equal to minus dt. Therefore, now this is first integral, that is as it is. This substitution is for only second integral. That is integral of 0 to a f of x dx, that is the first integral. In second integral, we have to substitute like this here. Then what it becomes here? What are the limits? Now if you take here, these are the limits of x here. If you put x is equal to a, then t becomes here, if you put x is equal to a, that is what it becomes here? It is t is equal to 2a minus a, that is equal to a you will get here. Therefore, it is minus of dt you get, here you can write a, that is the lower limit, because by we have to put x is equal to a. Then t is equal to a minus a, that is a, that is called as lower limit. Now upper limit, you have to substitute x is equal to a, x place lo 2a rasam, 2a get cancelled, minus t 0 and t is equal to 0 you got it. Then f of x means you have to write it as f of 2a minus t and minus dt we have to write here, because dx is equal to minus dt. where x is equal to 2a minus 2 at right and dx is equal to minus dt. So that now that is here, that is equal to, this is first integral as it is, that is 0 to a f of x dx you can write, plus, see if you interchange the limits 0 to a, then this becomes positive. If you interchange the limit, sign changes. So this becomes positive here. So like that, what it becomes here, it is integral of 0 to a you can write here. Integral of 0 to a f of 2a minus t dt. F of 2a minus t dt. Therefore, that is integral of 0 to a f of x dx plus integral of 0 to a f of 2a minus x dx here. If you change the change of variable property, 2a minus t dt can be written as 2a minus x. If you write here x, dx will get here. That is the first property of definite integrals. So here we can write now, if 2a minus x is equal to f of x, if f of 2a minus x is equal to f of x, then what it becomes here, it is integral of 0 to a f of x dx plus integral of 0 to a f of x dx will get. Therefore, these are two same terms, so that it becomes 2 into 0 to a f of x dx will get. 2 into 0 to f of x dx if f of 2a minus x is equal to f of x. Similarly, now if f of 2a minus x is equal to minus f of x, if you write here in this place, if you write minus f of x, then they get cancelled, so that we get it as 0 like this. Okay, is equal to 0 if f of 2a minus x is equal to minus f of x. This is also one of the important property, like this we can prove here. So by using this property, we can do some problems. If f of 2a minus x is equal to minus f of x, then it becomes 0, because you have to write here minus f of x. If you write here minus f of x, they get cancelled. This is with positive sign, this is with negative sign, they get cancelled, you got it as 0 like this. Now, so that is integral of 0 to 2a, integral of 0 to 2a f of x dx is equal to 2 into integral of 0 to a f of x dx. F of x dx, if f of 2a minus x is equal to f of x. If f of 2a minus x is equal to f of x, then it will be like this, and is equal to 0 if f of 2a minus x is equal to minus x, minus f of x, then that value is 0. Okay. Now, so for example, you can take, evaluate integral of 0 to 2 pi, integral of 0 to 2 pi sin power 100x, sin power 100x into cos power 99x dx. 0 to 2 pi sin power 100x into cos power 99x dx. Now, here f of x is equal to sin power 100x into cos power 99x. Then f of 2 pi minus x, f of 2 pi minus x, that is equal to sin of 2 pi minus x, that is minus sin x will get here, so that minus sin x whole power 100. And we know that cos of 2 pi minus x is cos x only, so that cos x to the power of 99. Here even power is there, so that it becomes plus only, that is sin power 100x into cos power 99x you got here, which is equal to f of x. So that now, so it is satisfied f of 2 pi minus x is equal to f of x. Therefore, that can be written as, this integral can be written as 2 into 0 to pi. 0 to pi sin of 100x into cos power 99x dx will get here. Now, again we have to, here you take f of x is equal to, it is sin of 100x into cos of 99x, then f of pi minus x, here pi is there, so that you can write pi minus x. And we know that sin of pi minus x is sin x only, so that sin x power 100 will get. Whereas cos of pi minus x is minus cos x will get, minus cos x whole to the power of 99. So that here odd number is there, minus power odd number, so that finally you will get minus sign. Minus of sin x to the power, sin power 100x into cos power 99x, which is equal to minus f of x. Therefore, this value becomes what here? It is 2 into 0 will get, that is 0. So, like this, by using this property, we can solve the problems like this. So, next one, that is here definite integral of odd and even function. Suppose here you can take minus a to a f of x dx, f of x dx. So, that can be written as integral of minus a to 0 f of x dx, minus a to 0 f of x dx plus 0 to a f of x dx, f of x dx. Okay. So, integral of minus a to a f of x dx is equal to, we can split into two integrals like this, that is minus a to 0 f of x dx plus 0 to a f of x dx. Now, here it is in this integral, if you put x is equal to, minus t, then dx is equal to minus dt. In first integral, if you substitute x is equal to minus t, then dx becomes what here? Minus dt. Therefore, now the first integral can be written as x is equal to, if you write here minus t, these are the limits of x here. If you substitute the lower limit of x, that is minus a here, then t becomes a here. That is the lower limit of t. And similarly, upper limit of x is 0 if you write here, then it becomes minus t is equal to 0. Therefore, t is equal to 0. That is the upper limit of t. Then f of, it is f of minus t, because x is equal to, and dx is minus dt, plus that second integral as it is you have to write, that is 0 to a f of x dx. Therefore, now that is we can also write, to remove this minus sign, we have to interchange the limits. That is, by writing the limit 0 to a, then it becomes positive. So that you can write here f of minus t dt, or you can write f of minus x dx. It is true for any variable. Instead of writing f of minus t dt, we can also write it as f of minus x dx here, first property of definite integral. Plus how much here? It is integral of 0 to a f of x dx, f of x dx. Like this will get here. So, here if f of x is, even function, if f of x is even function, if f of x is an even function, then f of minus x is equal to how much will get here? F of x. By the definition of an even function, that is f of minus x is equal to how much here? F of x. If f of x is an even function, then f of minus x is equal to f of x. So that what it becomes here, that integral becomes integral of 0 to a f of x dx we have to write here, first integral, and second integral is also 0 to a f of x dx. So that you got it as 2 into 0 to a f of x dx, 2 into 0 to a f of x dx. Now, if f of x is odd function, if f of x is an odd function, if f of x is an odd function, if f of x is an odd function, then f of minus x is equal to minus f of x. If f of x is an odd function, then f of minus x is equal to how much here? Minus f of x. Then here we had write minus f of x here. Therefore, what it becomes here? That first integral becomes 0 to a. In the place of f of minus x, we had write it as minus f of x. You write minus outside, and f of x dx. This is the first integral. And whereas second integral is 0 to a f of x dx here. So that they get cancelled. So that you got it as 0. So therefore, now what can you write here? It is integral, that is a definite integral of odd and even functions here. If the limits are in the form of minus a to a, then we have to see whether f of x is an odd function or even function. Depends upon that. If it is even, it will be equal to 2 into 0 to f of x dx you got here. So is equal to 0 if f of x is an odd function. Therefore, now we can write integral of minus a to a f of x dx is equal to, that is 2 into 0 to a f of x dx if f of x is even, if f of x is even function, and is equal to 0 if f of x is odd. If f of x is an odd function, then it will be equal to 0. So this is one of the important property of definite integrals here, that is integral of minus a to a f of x dx is equal to 2 into integral of 0 to a f of x dx if f of x is even, and is equal to 0 if f of x is an odd function. So by applying this property, we can solve some problems here. Now we can take evaluate integral of minus pi by 4 to plus pi by 4. Integral of minus pi by 4 to plus pi by 4. Here it is given x power 9 minus 3 into x power 5 plus 7 into x power 3 minus x plus 1 divided by cos square x, divided by cos square x dx, divided by cos square x dx. This is the problem given. So by applying this property, this odd and even function integration, now we can write this as, this integral can be written as, it is integral of minus pi by 4 to plus pi by 4 you can write. And 1 by cos square x is nothing but secant square x, so that you can write here secant square x you can write in the denominator like the numerator like this. And here it is x power 9 minus 3 into x power 5 plus 7 into x to the power of 3 minus x plus 1 dx. Therefore, now this can be written as integral of minus pi by 4 to plus pi by 4 secant square x into x to the power of 9 minus 3 into x to the power of 5 plus 7 into x to the power of 3 minus x dx plus integral of minus pi by 4 to plus pi by 4 and secant square x dx, secant square x dx, like this we can write. Because here we are taking this only these terms here, and secant square x into 1, that is secant square, like this we have to split this into. Here now we have to observe whether this function is even or odd. See, this is an odd function, this is odd function, and this is an even function. We are splitting this into odd and even like this, so that it is 0. If it is an odd, f of x is minus a to a f of x dx equal to 0 if f of x is an odd function. So that for first one we can write simply 0. Okay. And for second one, that is 2 into 0 to pi by 4. Limits are, that is 2 into 0 to pi by 4 secant square x dx we can write. Secant square x dx, like this we can write. 2 into integral of 0 to pi by 4 secant square x into dx. And we know that integration of secant square x is tan x. Therefore, that is equal to 2 into tan x you got here. And limits are 0 to pi by 4. Therefore, that is 2 into tan pi by 4 is 1 and tan 0 is 0. So that you got it as 2. That is the value of this integral. So, like this we can apply the definite integral of odd and even functions. Okay. So, we take one more problem here. Integral of minus pi to pi x into sin x by e power x plus 1 dx. Integral of minus pi to pi x into sin x by e power x plus 1. Here it is f of x is equal to that is x sin x by e power x plus 1. Now, suppose here if you write f of a plus b minus x, where a is minus pi, b is pi. So, f of a plus b minus x is equal to, it is nothing but f of minus x. So that it is equal to, you have to write in the place of x minus x, so that you get minus x and sin of minus x divided by e power minus x and plus 1. Or that can be written as, because minus sin of minus x is minus sin x, minus into minus becomes plus, so that you can write it as x sin x will get, divided by this e power minus x can be written as 1 by e power x you can write, so that by taking LCM e power x goes to numerator and denominator will be e power x plus 1 again. This is the value of f. See, first of all we have to apply this property, that is integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x dx, f of a plus b minus x dx. So, here let this integral is equal to, you take it as I, and then by using this property we can write it as I, that I can also be written as, by using this property, integral of minus pi to plus pi. Okay, f of a plus, that is you got it as x into sin x into e power x, x into sin x into e power x divided by e power x plus 1 dx. This is 2. Now, 1 plus 2 gives you equation 1 plus equation 2, that is 2i is equal to, that is here integral of minus pi to pi. So, we have to add these two functions here, this is under the same integral with the same limits, that is x sin x is common, then it becomes e power x plus 1 in the numerator. Already denominator is also e power x plus 1 for both the terms. Therefore, they get cancelled and simply you will get it as x sin x dx will get. it is equal to x sin x dx. Therefore, now this x sin x is it is an even function, because by replacing x by my f of this is, you take it as f of x, then f of minus x is also equal to f of x. Therefore, this is an even function, so that we can write it as 2 into 0 to pi x sin x dx we had write. Since f of x is an even function, here f of x is even function, f of x is even, so that you have to write like this, then 2 get cancelled. Therefore, that I is equal to integral of 0 to pi x into sin x dx, x into sin x dx. Now, we have to integrate this by parts method, then we have to substitute the limits. So, that is here first function, that is x, integral of second function, that is minus cos x, minus under integral differentiation of first function is 1 into integral of second function, that is minus cos x dx, and here that is equal to minus x cos x, and minus into minus plus integral of cos x is sin x, and limits are, that is 0 to pi, limits are 0 to pi. Therefore, now it becomes, that is I is equal to, here you got it as pi, x is equal to pi, you have to substitute, so that it becomes minus pi, x is cos of pi is minus 1 and sin pi is 0, and by substituting lower limit it becomes 0, so that it is equal to how much you got here, pi, I is equal to pi. Therefore, this value you got it as pi. Okay. Yes, any questions, any doubts? If any doubts are there, you call to that number which is scrolling on the screen. Yes. Yes, any doubts? Okay, then we do one more problem. If f of x is equal to, if f of x is equal to, that is x plus sin x, x plus sin x. If f of x is equal to x plus sin x, then find integral of pi to 2 pi, integral of pi to 2 pi f inverse x dx. Okay. Now, so now here it is given that f of x is equal to x plus sin x, x plus sin x. Then we have to find the integration of f inverse x dx. So here by substitution method we have to find the integration of that function, not for binding by finding the inverse of that function. Here suppose here if you put x is equal to f of t, then dx is equal to how much here, f dash t dt, f dash t dt, dx is equal to how much here, f dash t dt. Then given integral becomes, here it is that is pi to 2 pi, limits are pi to 2 pi here, f inverse x, f inverse x is nothing but t here, because x is equal to f of t, then t is equal to how much here, f inverse x. So f inverse x, and dx is how much here, it is f dash t dt, f dash t dt, t into f dash t dt. So the limits will be same, will get here pi to 2 pi, because here by substituting, here actually we are substituting x is equal to f of t, we are substituting here. X is equal to f of t, this is the substitution. Then what are the limits here? How you got this pi and 2 pi? See, x, these are the limits of x here, x plus, you are substituting the lower limit of x, that is pi. You want, now we need to find the limits of, what are the limits of t. So that here f of t means what it becomes, this is f of x is equal to x plus sin x. Then it becomes what here, t plus sin t, we are right, t plus sin t. Therefore, automatically then t will be how much here, it is pi only. Then only you get satisfy this, t plus sin t equal to pi implies that t is equal to pi. Pi plus sin of pi is 0. Similarly, this is the lower limit of t. Upper limit, to find upper limit you have to substitute x is equal to 2 pi. 2 pi is equal to f of t means you have to write here t plus sin t. Then this implies that t is equal to 2 pi. T is equal to 2 pi, if you substitute here, that only satisfies this equation here, sin of 2 pi is 0. Therefore, the limits are, these are the limits of t, not x. It will be same, pi to 2 pi you will get, t into f dash t dt. Now we have to integrate this by parts method by taking this is first function and by taking this as second function, because we need to find the, this is the derivative of f dash t. If you integrate f of t, you will get here, because integration is antiderivative. So that that's why we are taking this is second function. Therefore, it's we are applying by parts method, first function t, integral of second function, that is f of t, minus under integral, that is differentiation of first function, it is 1 into f of t dt, Therefore, that is t into f of t minus integral of f of t means we are right here t plus sin t. F of t is nothing but t plus sin t dt, we are right, t plus sin t dt, because f of x is x plus sin x given. Therefore, now it is t into f of t minus, here t integration is t square by 2, integration of t, integration of sin t is minus cos t, minus of minus plus will get, plus cos t will get, and limits are, that is pi to 2 pi, Therefore, now what it becomes here, by substituting upper limit which is 2, t is equal to 2 pi, if you substitute here, then what it becomes here, it is 2 pi you can write, and f of 2 pi, 2 pi into f of 2 pi minus pi into f of pi, by substituting the lower limit in this t into f of t, we are substituting upper limit 2 pi, then you got, by substituting lower limit you take with the minus sign, then pi into f of pi you got here. Similarly, minus t square by 2, that is you have to write here 2 pi, 2 pi whole square is 4 pi square by 2 means it is minus 2 pi square will get, and minus of minus plus, by substituting lower limit it is pi square by 2 will get here, pi square by 2 plus cos of 2 pi is 1, minus of minus 1 will get, because cos pi is minus 1. Therefore, then it becomes f of 2 pi. F of 2 pi means it is 2 pi only will get here, because f of 2 pi plus sin 2 pi, sin 2 pi is 0, sin n pi is 0. Therefore, its value is 0. Similarly, this is f of pi is also equal to pi you will get here, f of pi equal to pi plus sin pi, where sin pi is 0. Therefore, that becomes what here, 2 pi into 2 pi you are right here, minus pi into pi, okay, then minus 2 pi square plus pi square by 2 plus 2 you will get here. Therefore, this is 4 pi square minus 3 pi square, so that pi square plus pi square by 2, it becomes 3 pi square by 2 you will get, plus 2. That is the value of integral of pi to 2 pi f inverse x dx, like this we have to find here. Okay, we stop here. Any questions? Anybody? If you have any doubts, call me to the number scrolling on the screen. So, some more properties are there regarding this definite integral that will continue in the next class. Property and related problems that we will discuss. Okay, thank you. Okay. Yes. Any doubts are there? Okay.